Let's look at number 2. So it says write the augmented matrix for the system of equations and state the dimensions, then solve. So with number 2, we want to put it in order. A lot of people made that mistake on the quiz where it didn't give you the correct order for your x, y, and z, and you didn't notice. So I'm going to rearrange my equations and put them in order. So for the first one, I have 2x plus 2y minus 4z is equal to 4. The next one, we have 3x minus y minus 5z is equal to 8. And then here, I'm just going to switch the order that I have. So I'm not really moving things to the other side. I'm just going to put that equals -7 on the other side. So we've got 2x plus y plus 2z is equal to -7. When we write our augmented matrix, we're just writing the coefficients. So our first row would be 2, 2, -4, and then 4. Our next row would be 3, -1, -5, 8. And then the third row would be 2, 1, 2, and -7. So this would be our augmented matrix. What's the size, what's the dimensions of the augmented matrix? A 3x4, awesome. We've got 3 rows and 4 columns. Last thing we want to do here is solve. So going back to our matrix here with the x, or not the matrix, but our system of equations with the x, y's, and z's, let's solve. Which variable do you want to eliminate first? I think y would be the easiest to choose from. Our coefficients for 2 of them are 1 and the other one's 2. So we've got small numbers that we're working with here. I'm going to label my equations. We've got 1, 2, and 3. Which 2 do you want to combine first? 2 and 3 would be a great choice because we see that the y's are already going to cancel. So 2 and 3. We've got 3x minus y minus 5z is equal to 8. And 2x plus y plus 2z is equal to -7. So here we have 5x, the y's cancel, minus 3z is equal to 1. Be super careful with the signs when you're adding. Just be careful with the little math that you got going on. What should I do next? Remember, we have to do this step twice. So which 2 other equations do you want to combine together? 1 and 2. Awesome. So 1 and 2. So we've got 2x plus 2y minus 4z is equal to 4. And 2 is 3x minus y minus 5z is equal to 8. What do I need to multiply by to get the y's to cancel here? I need to multiply the second equation by 2. So everything's going to get multiplied by 2. I'm going to write it just above here so it's easier for me to see and combine them together. We've got 6x minus 2y minus 10z is equal to 16. So this is my new second equation here. So I'm going to combine these together now. This gives us 8x, the y's cancel, minus 14z is equal to 20, equals 20. Everybody agree so far? What do we do next? We got to combine these 2 equations together. So when we combine these 2, we've got 5x minus 3z is equal to 1, and 8x minus 14z is equal to 20. Do we have a variable that's going to cancel here? Not yet. Which variable do you want to make cancel? X would be a good choice. What do we need to multiply by our first equation? -8, so everything gets multiplied by -8, so our new first equation is going to be -40x plus 24z is equal to negative 8. What do we need to multiply by our second equation? 5. Awesome. Everything in our second equation is going to get multiplied by 5. So now we have 40x. Negative 14 times 5 would be 70. Negative 70z is equal to 100. The x's now cancel. 24z minus 70z would be negative what? 46z is equal to 92. Divide both sides by negative 46. So z is equal to what? Negative 2. So z equals negative 2. What could we do next? We can plug in z into one of our two highlighted equations, so one of the ones with two variables. So I'm going to plug it into the one on the left here. So we have 5x minus 3 times negative 2 equals 1. So 5x plus 6 equals 1. Subtract 6 on both sides. 5x is equal to negative 5. Divide by 5. So x is equal to negative 1. So we've got x, we've got z. Last thing we need to do is find y. So we can plug it into one of our three original equations. All the numbers in each one of the equations look pretty small. I'm just going to plug it into 3. So we've got 2 times negative 1 plus y plus 2 times negative 2 equals negative 7. So negative 2 plus y minus 4 equals negative 7. So we've got y minus 6 equals negative 7. We're going to add 6 to both sides. So what does y equal? Negative 1. How do we write our answer? Awesome. Negative 1, comma negative 1, comma negative 2. Perfect. So write it as an ordered triple. You need to write your answer as an ordered triple. People lost points on the quiz because they just gave me x equals, y equals, z equals. Remember, you have to write your answer as an ordered triple. So this question kind of had 3 questions in one we had to solve. We had to write it as an augmented matrix and state the dimensions. So make sure you know how to do all 3 of these things. Number 1 asks us to write the augmented matrix for the system of equations and state the dimensions and then solve. So the first thing we want to do is make sure that it's in order. We've got our x's, y's, and z's, so it's in order. Then we can write it in our augmented matrix. So we've got a column for the x's, a column for the y's, and a column for the z's. Starting with the first row, we've got 4, negative 1, 1, and then it's equal to negative 3. Second row would be negative 1, negative 4, 6, and then it's equal to 15. And then third row would be negative 2, 3, negative 5, and it's equal to negative 11. So just make sure that when you're copying down each row that it goes x, y, z. It's in order. Some of the questions on the quiz had the numbers flipped and people did not notice. So make sure you pay attention to that. What is the size of our matrix? A 3 by 4. Awesome. We've got 3 rows and 4 columns. So it is a 3 by 4. Second thing we have to do is solve. So we're going to solve our matrix. Which variable do you want to eliminate? X, Y's, or Z's? Sure, we can eliminate the X. So I'm going to name my equations. We've got 1, 2, and 3. Which 2 do you want to combine first? Sure, let's do 1 and 2. So we've got 4x minus y plus z is equal to negative 3. And 2 is negative x minus 4y plus 6z is equal to 15. What do we need to multiply by and to which equation to get the x's to cancel? Awesome. Let's multiply 4 to our second equation. So everything gets multiplied by 4. So our new second equation is negative 4x minus 16y plus 24z is equal to 4 times 15 would be 60. So this is our new second equation. Let's combine these two together. Do the x's cancel? Yep, so we're left with negative 17y plus 25z is equal to 57. What should we do next?
Get rid of x for the second equation.
Awesome. Let's combine two other ones, but we still have to get rid of x. So we can combine the second and third equation now. So 2 and 3. 2 would be negative x minus 4y plus 6z is equal to 15. And 3 is negative 2x plus 3y minus 5z is equal to negative 11. So what do we need to multiply by and to which equation to get the x's to cancel here? Awesome. We're going to multiply negative 2 to our first equation here. So we get positive 2x plus 8y plus 12z is equal to 30, negative 30. Sorry, this should also be minus 12z. Super important that your signs are correct. Don't make a mistake in the beginning because it'll throw everything else off. So just be careful with the math. So this is our new first equation. Let's combine these two together now. The x's cancel. We have 11y minus 17z is equal to negative 41. What should we do next? Let's combine these two equations together. So negative 17y plus 25z is equal to 57. And 11y minus 17z is equal to negative 41. So which variable do you want to cancel now?
Y.
Sure, we can cancel out the y's. What would we need to multiply by to cancel the y's?
First one by 11 and the second one by 17.
All right, we're going to multiply the first one by 11 and second one by 17. So everything in our first equation gets multiplied by 11. So 17 or negative 17 times 11 would be 187. Negative 187y. 25 times 11 would be 275 z. 57 times 11, let's write it out. We've got 57 times 11. $627. Then we're going to do the same thing with the second one. We're going to multiply everything in our second equation here by 17. So 11 times 17 would be negative 187y. Oh, sorry, it's positive here. This would be negative 17 times 17. Let's write it out. 7 times 7 is 49. 7 times 1, this would be 11. 289. z is equal to 41 times 17. So 697, negative 697. Now do our y's cancel? Yes. So y's cancel. 275z minus 289z would be negative 14z. And then 627 minus 697 would be negative 70. Divide both sides by negative 14. What is 70 divided by 14?
5.
Awesome. Positive 5. So we found z. What can we do next? We can plug into z into one of the two highlighted equations. It doesn't matter which one. I would recommend the one with smaller numbers, but they both kind of have big numbers here. So I'm just going to plug it into the one on the left. We've got negative 17y plus 25 times 5 is equal to 57. So negative 17y plus 25 times 5 would be 125. Equals 57. Subtract 125. Negative 17y is equal to 57 minus 125. 68. Then divide both sides by negative 17. Awesome. So y equals 4. Last step, we still need to find x. So let's plug it into one of our original equations. It doesn't matter which one. I would recommend the one with smaller numbers, but they've all got about the same size. Let's plug it into the first one. So we have 4x minus 4 plus 5 equals negative 3. So 4x plus 1 equals negative 3. Subtract 1 on both sides. 4x equals negative 4. Divide by 4, x equals negative 1. How would we write our answer? As an ordered triple, what would come first? Negative 1, 4, and then 5. So x, y, then z. Don't forget to write your answer as an ordered triple. People forgot on the quiz and lost points. All right, let's look at 3. So we want to solve for x. First thing we want to do is solve our little equation here for x, and then we're going to plug in our matrices and do whatever the math tells us for our matrices. So when I solve for x here, I want to add a to move it to the other side. So 2x equals 5b plus a. Then what should we do next? Divide by 2. So x is equal to 5 times b plus a over 2. So we're going to do exactly what it tells us here with our matrices. The first thing I want to do is find what 5 times b is. So I'm going to take my matrix B and I'm going to multiply it by the scalar of 5. So 5 is going to get distributed to every number in our matrix. Five times 8 would be 40. 5 times negative 1 is negative 5. 5 times 7 is 35. And 5 times 1 is 5. So we found 5b. Next, we want to add a to it. So the second thing I'm going to do is add a. I'm just going to rewrite our matrix A right next to it just so I can see it a little bit better, make it easier for us to add. So 5b plus a is going to be 40 plus 1 would be 41. Negative 5 plus 0 is negative 5. 35 plus negative 2 would be 33. And 5 plus 4 is 9. So this would be 5b plus a. We've got one last step to do. The last thing we want to do is divide by 2. How else could we say divide by 2? We can times 1/2. So we're going to multiply this by the scalar of 1/2. So that's going to get distributed to everything in our matrix. Lucky for us, these are all odd numbers, so nothing simplifies. So we've got 41 over 2. Negative 5 over 2. 33 over 2. And 9 over 2. Always, always, always simplify if you can. But here, nothing simplifies. So you don't have to turn it into a decimal. You don't have to make it a mixed number. Just simplify your fraction if it simplifies. We don't have any common factors here. Nothing simplifies. So this would be our answer. Next, let's look at 4. So here we have matrices and we want to solve for x. So first thing we want to do is solve for x in our original equation here, in the equation that we're given. Then we can plug in our matrices after we find what x is equal to. So what would I do first here to solve for x? Subtract a. So 4x is equal to 2b minus a. Then what? Divide by 4. So x is equal to 2b minus a over 4. You can simplify if you want and multiply 1/2 times b and then a times 1/4 and then subtract them. I think it's going to be easier to combine your matrices first and then do any dividing that you have. So first thing I want to do here is find what 2b is going to be equal to. So I'm going to take my matrix B and multiply it by the scalar of 2. So 2 gets distributed to everything inside of our matrix. So this would be 4, 2, 2, 2. So this is 2b. What should we do next? Subtract a. Awesome. We're going to take 2b and subtract a. So a, I'm going to rewrite right next to it to make it a little bit easier for us to subtract. It would be 1, negative 1, negative 1, 2. So when we subtract here, we have 4 minus 1, which would be 3. 2 minus negative 1. Be super careful with the signs. Minus a negative would turn into plus. This is 2 plus 1, which would be 3. 2 minus negative 1 would be 2 plus 1, which is 3. And 2 minus 2, which is 0. So this is 2b minus a. What's the last thing that we have to do? Divide by 4. So instead of dividing by 4, what else could I do? Multiply by 1/4. When we multiply by 1/4, it gets distributed to everything. And make sure you simplify the fractions where you can. Here, nothing simplifies. So we have 3/4, 3/4, 3/4, and 0. So this would be our answer. This is x. So for number 5, it says find the following or explain why the operation cannot be performed. So let's do the first one here. We've got 4a minus 5b. So 4, I'm going to multiply to a, and 5, I'm going to multiply to b. Can I subtract a and b together? Yeah, they're the same size, so we can add or subtract them. Remember, they have to be the same size in order to add or subtract. What about b and c? What if this question asked me to find b plus c? Could I add these together? No, this would be not possible. On the test, you need to explain why. We could just say they are not the same size. So in order to add or subtract, they have to be the same size. So let's find 4a, and we'll subtract 5b from it. So first, let's distribute 4 to a. So we get 16 minus 4. 4 times 7 would be 28. 28. 4 times 3 is 12. 4 times 5 is 20. Minus 5b. Now you could do this a couple different ways. If you wanted to multiply negative 5 to everything in b, you could do that and then add them together. Or just distribute the 5 and subtract. I'm just going to distribute the 5 and we'll leave it as a minus, but just be careful with your signs. So when we distribute the 5, we get negative 20. 5 times 6 would be 30. 5 times 3 is 15. 5 times 8 is 40. 5 times negative 3 is negative 15. And 5 times 9 is 45. Now let's subtract. So be careful with your subtraction. First we have 16 minus negative 20. If you need to write out each step, write it out, do it one at a time. When we have minus a negative number, it turns into plus. So 16 plus 20 would be what? 36, perfect. Then negative 4 minus 30 would be negative 34. Then 28 minus 15. What's 28 minus 15? 13, awesome. Then we have 28 minus 40. What's 28 minus 40? 28 minus 40. Negative 12, perfect. 12 minus negative 15. So again, this turns into a plus. 12 plus 15 would be 27. And then lastly, 20 minus 45. Negative 25. So just be careful with the math. The test is no calculator. Take your time with all of the little math that you got going on. If you make a mistake with multiplying or distributing in the beginning, it's going to throw off the rest of your answer. So just be careful with every step. Any questions here? Perfect. Let's do b times a, so the second one. First, let's figure out our dimensions for b and a. What's the dimensions of b? A 2 by 3. What's the dimensions of a? A 2 by 3. Can I multiply a 2 by 3 times a 2 by 3? Why not? The middles are not the same. So we can't multiply. So this would be an explanation enough, just saying that the middles aren't the same. Show me this. Just don't say, can't multiply. Don't just say, not possible. I need to see why. This is a perfect reason why. This is all you need to do. You don't need to write a sentence out. Just show me this. Middles aren't the same, so we can't multiply. Next, let's see if we can multiply a times c. What's the dimensions of a? A 2 by 3. What's the dimensions of c? A 3 by 2. Can we multiply these together? Yes, the insides are the same, so we can multiply. What's the size of our answer going to be? A 2 by 2. Perfect. So I'm going to draw a 2 by 2 down here for us. So I know that I'm going to have 2 rows and 2 columns. I'm also going to rewrite a and c down here just so I can see it a little bit better to make it easier for us to multiply. So a is 4, negative 1, 7, and 7, 3, 5. And c is negative 5, 6, 4, and 7, negative 4, 9. So in our first matrix, we move in rows. The second matrix, we move in columns. So the order that you multiply matters. So we're starting with the first row, first column. So we're going to multiply the first number times the first number. 4 times -5 would be -20, plus the second number times the second number. -1 times 6 would be -6, plus the third number times the third number. 7 times 4, 28. What's -20 minus 6 plus 28? 2. Awesome. Let's do it again. Next, we stay with the first row. Let's do the second column. So that's going to go in the first row, second column spot. First, we have 4 times 7, which would be 28. -1 times -4 would be 4. And 7 times 9 would be 63. So 28 plus 4 plus 63. 28 plus 4 would be 32. 32 plus 63 would be 95. Next, we have the second row, first column. 7 times -5 would be -35, plus 3 times 6 would be 18, plus 5 times 4 is 20. -35 plus 18 plus 20 would give us what? 3. Awesome. Bless you. Any questions there? We've got one more number to find. Let's do the second row, second column, and that's going to go in the second row, second column spot. So 7 times 7 would be 49. 3 times -4 would be -12. And 5 times 9 would be 45. So we have 49 minus 12 plus 45. We can do 49 minus 12 would be 37. 37 plus 45 would give us 82. So this would be our answer. All right, let's do 6 next. We want to find the inverse of the matrix. If there is not one, state no inverse. So first thing we want to do to find the inverse is find what our scalar is that we need to multiply. So it is 1 over majors minus minors. So 1 over, when we multiply the majors together, that'd give us 9 times 7. It's 9 times 7. 63 minus the minors, which is 6 times 8, or -6 times -8. What's -6 times -8? 48. Perfect. And 63 minus 48? Awesome. 15. Positive 15. So we get 1 over 15. So that's going to be our scalar. Now we need to multiply that times our new matrix. What do we do with the majors? Switch the majors. So 7 now goes up top and 9 goes on the bottom. What do we do with the minors? Change the signs. We negate them. So we just flip the signs. If they're already negative, we got to make them positive. So -8 is going to turn into +8, and -6 turns into +6. Now the last thing we want to do is distribute our scalar to everything. So we get 7 over 15. We can't simplify that. 8 over 15? Can't simplify that one. What about 6 over 15? Can I simplify 6 over 15? Perfect. We can divide them both by 3, so this gives us 2 over 5. Awesome. And what about 9 over 15? Can we simplify that? 3 over 5. So this would be our inverse. Last step, we just need to name it as the inverse. So make sure you put the little inverse symbol. All right, let's do a determinant question. So let's find the determinant of a 3 by 3. Let's do 9. What's the first step we need to do to find the determinant? Awesome. We're going to rewrite the first two columns on the outside. So we've got 4, 2, 0, and 3, negative 1, 5. Now, same thing we did when we had our inverse question. We do major minus minors. So here we've got 3 majors. We'll have 3 minors, but let's just start with majors. So we multiply all 3 numbers in each major. So 4 times negative 1 times 1 would be what? Negative 4. Awesome. Plus 3 times 0 times 0. 0. And then 8, negative 8 times 2 times 5. Negative 80. Awesome. So negative 4 plus 0 minus 80. Negative 84. So that would be our majors. We add up all the majors together. Then we minus the minors. I'm going to put it in parentheses because I'm going to add up all of our minors together and then subtract it at the end. So our minors start at the bottom corner and go up. We've got 3 minor diagonals. Our first one would be 0 times negative 1 times negative 8, which gives us what? 0. Then 5 times 0 times 4, which would be also 0. And then 1 times 2 times 3, which is 6. 0 plus 0 plus 6 is 6. So major minus minors would be 84 minus 6. What's 84 minus 6? Negative 90. Perfect. So that would be our determinants. So for 7, we want to find the inverse to the matrix. First thing we need to do is find our scalar. So we have 1 over major minus minors to find our scalar. Majors start up at the top. So this would be 1 over, what's negative 9 times negative 8? 72. Minus the minors would be negative 12 times negative 6. What's negative 12 times negative 6? 72. So we have 1 over 0. This would be undefined. So do we have an inverse? No inverse. All right, let's do number 8. So same thing, 1 over majors minus minors. Our majors would be 7 times 8. What's 7 times 8? Majors start up at the top left. So like the first number, that diagonal is going to be our major. 56, thank you. Minus the minors start up at the bottom. So this diagonal would be our minor. So what's 4 times 33? Awesome, 132. What's 56 minus 132? So 1 over negative 76. Perfect. Now that's our scalar. We're going to multiply that times our new matrix. What do we do to the majors in our new matrix? Switch the majors. So they switch, we get negative 8 up top and negative 7 on the bottom. What do we do to the minors? Negate them. We change the signs of them. So it would be negative 33 now up top and negative 4. And then we're going to distribute our scalar, which is 1 over negative 76. When we distribute it, make sure you simplify all of your new fractions. So this first one, we have negative 8 over negative 76 would be 8 over 76. It's going to change to positive. Does 8 go into 76? No, but 4 does. 19 times. So we have 2 over 19. Then we have negative 33 over negative 76. Do we have any common factors between 33 and 76? Nope. So 33 over 76. All right, so this is our answer. So just make sure you simplify the fractions where you can. Any questions here? All right, let's do 10. Last one. We're going to find the determinant of a 3 by 3. What's the first thing we need to do to find the determinant? Write the first 2 columns next to it. So 1, 2, 3, negative 3, negative 2, and negative 1. So let's start with our majors. Remember, it's majors minus minors. So our majors start up at the top left. Those are our major diagonals. We multiply the numbers together in each diagonal. What's 1 times negative 2 times 3? Negative 6. Plus, what's negative 3 times negative 1 times 3? 9. Plus, what's 2 times negative 1? Negative 4. So we have negative 6 plus 9 minus 4. What do we get? Negative 1. Awesome. That would be our majors minus the minors. So minors start at the bottom corner. And the diagonals go up this way. So our first one, we have 3 times negative 2 times 2. Negative 12. Perfect. Negative 1 times negative 1 times 1. 1. So plus 1. And 3 times 2 times negative 3. Negative 18. So let's find what our minors added up together is. What's negative 12 plus 1 minus 18? Awesome, negative 29. So we have negative 1 minus negative 29. When we subtract a negative, this turns into a positive. So it's negative 1 plus 29. 28, positive 28. So that would be our determinant.